Hi guys, welcome to another episode of MrLopezClasses.com. Today we are going to continue in our book of air conditioning systems. And today we are going to talk about the self-contained unit. Self-contained air conditioning unit, they are more popular every day in small boats, medium boats, because the unit, like the name said, is in one unit, the condenser and the evaporator together is better than the split unit. We are going to explain today in the episode why it's more efficient than the split unit. Today we are going to visit again MABRU power systems, and we are going to speak with Nicholas MABRU about those units, and we are going to talk and specific about unit, self-contained unit, DC powered, produced for MABRU, and units in 4.2 thousand BTUs, in 7,000 BTUs, in 14,000 BTUs, 16,000 BTUs. Great unit. Okay, my friends, the efficiency. Some years ago, we considered that the air conditioning units DC powered are not efficient because they drain the batteries easily. Basically because the compressor, the peak of the compressor at the beginning is the consumption in amps is too much and drain the batteries easily. Today, the air conditioning equipment that we are going to analyze today, the compressor is magic because the compressor works in a low range of consumption in amps and start all the time in that fluctuation in a low range of consumption. We are going to check, we are going to measure the consumption of those equipments. Those are wonderful equipment. Okay, the compressor today, they don't have the peaks of the air conditioning equipment, AC powered, with the high peaks at the beginning when the compressor starts. This is the most important. And the second one is the quality of the batteries. Today, the batteries produced for MABRU, those batteries, is a lithium iron phosphate. Those batteries are magic. They store us a lot of amps for a long period of time. With those batteries, you can run an equipment 7,000 BTUs, full RPMs for 4 hours. Okay, if you combine batteries of those in a series and parallel, you can extend the period of time. This is magic. This is the secret for the production of BTUs in this type of unit. We are going to talk right now with Nicholas about the efficiency. What about the efficiency of the DC equipment, Nico?
410 is still a good gas to use on traditional systems or on larger systems.
Yeah, okay.
But to reach the efficiency levels that we wanted to be at, the best solution for us was going with 134.
Okay, and in other words, I saw that you recommend for medium and small boats basically every day more and more self-contained units.
Yes.
What about the split units?
Split units are something that were very popular up until the early 2000s.
Correct.
Because the units were extremely noisy. You have the compressor kick on, it was under your bed, your whole bed would shake.
And you have too much refrigerant in between both units, no?
And so the problem with the split, so it was good to have that noise away in the engine room.
Correct.
Now, the split systems are highly unchanged since the 80s.
Correct.
We're still using piston compressors, we're still, maybe they've changed the evaporators around a little bit.
Correct.
But once again, like you said, yes, you're gonna have to pump that refrigerant all the way from the engine room, all the way to the unit, and it's a lot more complicated to troubleshoot problems.
Correct.
Here, if you have a repair to do, okay, you can remove the entire unit. Let's say you have to replace it, you remove this, you put a new one in, you start from scratch. With the split systems, maybe you change the evaporator and you keep the other condensing unit in the engine room. Maybe you change the condensing unit. But if there's a leak, let's say there's a leak in that line that goes from the condensing unit.
Correct.
It becomes a lot more difficult to troubleshoot, and I see a lot of customers having problems.
And it's less efficient, no?
Much less efficient.
It's less efficient. Okay. And I saw also that those equipments depend of the battery, and the battery depend of the inverter charger or battery charger. But you don't need, like in the past, inverter dedicated for the air conditioning system. What about the new inverters?
So new inverters, we're talking about the new inverters. We made a lot of jumps on true sine wave technology. or pure sine wave technology, however we want to be calling that one. But it's really a clean wave, and what we're able to do is we're able to do a generator replacement.
The generator. That's the secret. That's the solution. And you integrate the air conditioning equipment with the generator.
Okay. As far as the generator, I would say if I'm gonna have a generator in the boat, I would not have a 12-volt system. I would have a 115-volt system.
Okay. You prefer the AC equipment with the generator.
Yes.
Perfect.
Unless I'm dealing with a situation where I have a very small generator for a lot of loads.
Correct.
And I need more efficiency on the system. At that point, we want to look into how we can become more efficient.
Correct.
So some boats don't have the space for a generator, but they really want a generator, or they don't want to run the generators for a significant period of time. We have customers that want to sleep at night with no generator running, but they don't mind running it through the day.
Correct.
So they'll have a lithium bank, they'll have a generator, they'll use their generator to recharge the batteries, or they'll have a solar array.
Correct.
Recharge
The generator
batteries.
is used to recharge the batteries.
Yes.
Yeah.
Yes.
Okay.
Yes, those equipments are highly efficient. Okay, and now we are going to analyze the performance of those equipments in comparison with the traditional AC powered equipment, self-contained single phase and double phase. Of course, the DC equipments are highly efficient, less noise, less vibration, and the consumption is wonderful. Some years ago, other manufacturers, they offer different options with the AC units powered with the AC current. I remember a small self-contained unit with an inverter, and the inverter, of course, with the bank of batteries. But once again, because the compressors, the peak of the compressors at the beginning of each cycle discharge the group of batteries easily, and that was an inconvenience. Other inconvenience some years ago was, okay, I like the air conditioning equipment, it's a single phase, double phase, AC powered, but I need to run my generator all the time. And during the evening, my boat is a small boat, I have the inconvenience of the sound of the generator. In this particular solution, we have a DC air conditioning equipment, and you use the generator sporadically for a short period of time only to charge the group of batteries. That's simple. And you don't need the big generator, because right now the generator could be a small generator only to supply power for the house of the boat and for the battery charger. This is good. You only start the generator for 10 minutes, 20 minutes, or something like this. You charge with the battery bank, you charge with the battery charger, the group of batteries, and right now you have air conditioning equipment for other 8 hours, or depending the configuration of the battery bank. This is a great solution. No, Nick?
I remember some years ago, some manufacturers, they sell the solution, an air conditioning equipment DC volts with the group of batteries, but the problem was the group of batteries. And after that, they sell a solution, an AC air conditioning unit, AC power, 240 volts with inverter, but the inverter drains the batteries easily. No?
So it's a combination. Once again, it's we haven't had this level of integration. The issue of the systems of the past and the 12-volt systems of the past is that we're talking about a simple on-off compressor, either piston or rotary. It has very high peak starting amps. So when that first hits, it's taking the batteries down every time that compressor has to come on, because we're going almost triple the running amps of the unit every time it starts. Then once it's running, it's drawing a lot more power. A 12,000 BTU, this same unit that we make in 115 volts, draws more than double what this unit draws just running.
Oh, really?
And these units don't have peak starting amps. They start slowly.
Okay. In AC, in 220 volts AC.
No,
No,
the
in
12-volt systems.
the 12-volt system.
They
Okay.
have it's a slow start. They don't have a peak startup. You'll see the amperage climb up when the unit starts up. It'll start, lower comes on. You'll be drawing somewhere around 6 amps at 12 volts.
Okay.
And then you'll slowly see the amperage start increasing.
Yeah.
Doing the same thing with a 115 volt system, whether it be ours, whether it be one of our competitors, you're going to see the same thing every time. I've done this unit, or I've done the 115 volt counterpart of the 12,000 BTU in a comparison side by side, both of our systems, which, as far as efficiency goes, our 12,000 BTU 115 is still going to be one of the more efficient options in the market.
Oh, okay, good.
Even like that, I was drawing over 300 amps when that 12,000 BTU 115 volt compressor was kicking on through the inverter.
Yeah, yeah.
I was drawing right around 100 amps running normal, and that wasn't accounting for a pump. So we also use very efficient pumps. If you use a standard pump, some sort of a bait well pump or a March pump going through an inverter, you're talking about 1 amp at 115 volts.
Yeah.
You're talking about 10 amps extra on top of that. So everything is about the efficiency. Everything is about reducing those amps.
Yeah.
Yes, my friend, this is a wonderful equipment, and the magic situation is the batteries, the quality of those batteries. Then I asked to Nicholas about those batteries.
Yeah.
Because you can put as big a battery bank as you want. You
Yeah,
can do,
of course.
I can put one battery. So let's say on this unit it's 4 hours. So we'll call it 2.5 times. So let's say I put 3 of these batteries, and we'll say, okay, I'll have the same runtime. Well, in theory, yes. The problem is, then we go to the recharging.
Yeah.
So for an alternator to keep up with a 44 amp charge, a 44 amp discharge, I'm sorry, it can handle it. Most alternators of today, whether we're talking about Yamaha, whether we're talking about Suzuki, whether we're talking about Mercury,
Yeah.
they can handle that kind of punishment over an extended period of time.
In other words, I can integrate those DC air conditioning equipments with my outboards, with the alternator of those outboards.
Or your inboards, exactly.
Or inboard, exactly the same. Oh, wonderful. Because the alternator, they have the capacity to recharge those great batteries.
Yes.
Oh, nice.
So we'll talk about one of the crazier installs that we've done. So we did one boat where we had 2 Mercury 300 Verados, the new V8s, and we had 3 of these units put in.
Oh, yeah, wonderful.
So we had 2 7,000 BTUs and we had 1 12,000 BTU. We had all 3 units running at full speed, drawing as much power as they possibly could.
Yeah.
Producing as much cold as they possibly could. And we wanted to see at what RPM we would need to be at to be able to maintain the units running, because it's a very important question.
It's a great question, yeah.
And what we came up with was, at 750 RPMs, both engines at 750 RPMs, we were able to not only maintain the 3 AC units running, we were able to put an additional 10 amps back into the battery bank.
Oh, you have extra amps. Oh, wonderful. Yeah.
So the idea is, if they go out on their boat and they want to run all 3 AC units and they're running at anything above 750 RPMs or 750 RPMs and above, they're going to be able to run their AC unit forever.
Forever.
It's not a situation of, I have to think about load management, I'm going to have to turn off this system. No, everything's going to be able to run and you don't have to think about your batteries.
That's incredible.
And the other magic situation is the consumption in amps. We have an air conditioning unit running, of course, at the maximum peak of efficiency, and this is the consumption in amps.
So to look a little bit more into that, what we can do over here is we're going to switch to DC amps.
DC.
And we're going to look at what the unit's drawing right now.
27 amps DC.
So 27.8, and here we're running at full speed. I'm not running a pump right now, so we'll add an extra 2 amps for that, so we'll say 30 amps.
30 amps, that's correct.
Here we have our new color touch display. So when we look at the display, we're going to go up on the temperature. So I'm set right now for 65, so I have a very big difference from the ambient temperature right now to the temperature I'm set for. So I'm going to now go up a little bit, and I'm going to bring this to 75. If we look at the amperage, I've now dropped down to 22.
Yeah, go down. Oh, okay.
So the idea behind this unit is that the unit will almost never be shutting down.
This is another demonstration of efficiency.
Absolutely.
That's perfect.
Great, this is a magic equipment. For that reason, I recommend check those equipments. There are MABRU is one of the manufacturers that is dedicated to innovate in batteries, innovate in air conditioning equipment. I recommend visit the webpage of them, and of course there are other manufacturers with other great equipments. But today there are a lot of equipments, air conditioning equipments, DC powered.